Today we're going to talk about tangent lines. Essential understanding says its radius of a circle and the tangent that intersects the endpoint of the radius on the circle have a special relationship. So a tangent to a circle is a line that intersects the circle in exactly one point. So in our drawing, point B is the point of tangency. And this is line AB, which is the tangent line. We say line AB is the tangent to the circle. The point where a circle and a tangent intersect is the point of tangency. Now, when you have a tangent line, such as line AB, certain angles are formed. The first line is if the line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So here we have circle O. Line AB is tangent to circle O at point P. Therefore, if you draw out the radius from 0 to P, O to P, this line is perpendicular to the tangent line. So therefore, OP is perpendicular to line AB, which is the tangent line. The next rule is the line in the plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent. So this is the converse of the original theorem. So if AB is perpendicular to radius OP at point P, then line AB is tangent to circle O. So you can show if a line is tangent by declaring whether or not it's a perpendicular line. If it's a perpendicular line, that means it's a right triangle, and that means you can use Pythagorean theorem to solve it. So line segment PT is tangent to circle O. OQ is 5, which also means that OP is 5 as well. And QT, from this point to this point, is 8, which makes this entire segment here, OT, 13 units. Okay, notice that if PT is tangent, then this line OP is perpendicular. So we have a right triangle that has a leg of 5, a hypotenuse of 13, and we want to find the length of PT ultimately. So OT is going to be 5 plus 8, which is 13. OP is given because this section from right here is a radius. This is a radius as well. So it's going to be 5. To find PT, take 13 squared equals 5 squared plus PT squared. Okay, we get 169 equals 25 plus PT squared. Subtract from both sides, we get 144 equals PT squared. Taking the square root of both sides, PT equals 12. And it's actually the Pythagorean triple. The next example, we want to determine whether or not circle O or circle D has a tangent line CE. Well, we need to find out if this is in fact a right triangle. So we use Pythagorean theorem. So if tangent angle E is a right angle, so does 45, because it's the longest side, equal 43 squared plus 11 squared? Well, 45 squared is 2025. 43 squared is 1849 plus 121, or 11 squared. Well, 2025 does not equal 1970 when combined, therefore it's not tangent. Okay, so in fact, c squared is larger than a squared plus b squared, so the angle is obtuse. Now the next theorem states that if two tangent segments in a circle share a common endpoint outside the circle, then the two segments are congruent. So, if line segment BA and line segment BC are tangent to circle O, you know this is perpendicular. Okay, so OA is perpendicular to AB and OC is perpendicular to BC. Okay, and we can use triangles are congruent by HL theorem to state a line segment BA is congruent to BC. Okay, so these two segments here are congruent. We are not going to go through the proof. For example, line segment PQ and line segment PT are tangent to circle O if PQ is x squared. Okay, so let's draw this. Here's Q, here's T. Don't worry about perfect drawings. Okay, this is x squared, this is 5x plus 6. We want to find x and find the length of PT. So, x squared equals 5x plus 6. Okay, solving this, we have to get it equal to 0. We're going to do x squared minus 5x minus 6 equals 0. Okay, we're going to do this factoring by grouping. We'll get x squared plus x minus 6x minus 6 equals 0. Factoring out an x from this group, factoring 6 from this group, we end up with factoring of x minus 6 times x plus 1 equals 0. Two solutions. Solving for each. X minus 6 is 0, or x plus 1 is 0. We end up with x equals 6, or x equals negative 1. Okay? If x equals 6, we end up with PT equal to 5 times 6 plus 6 equals 36. Or, if it's negative 1, PT equals 5 times negative 1 plus 6 equals 1. Most likely this is the correct answer. So, next example. Line segment AB is tangent to circle C at B. AD is tangent to circle C at point D. Find the value of x. Okay, our rule says that these two are congruent. So we get x squared minus 4 equals 21. Okay, x squared equals 25. Take the square root of both sides, we get x equals plus or minus 5. Okay, and we can rewrite this as negative 5 and 5 as a set. Okay, our next example, again, these are congruent. So x squared plus 8 equals 44. X squared equals 36. 36 is a perfect square. Take the square root of both sides, x equals plus or minus 6. Two more examples. Okay. Okay, we are going to skip the next example, and we're going to go into the last example. Okay, you are standing 14 feet from a water tower. The distance from you to a point of tangency on the tower is 28 feet. What is the radius of the water tower? Okay, so here's what we know. AC is R plus 14. B is one of the legs of the right triangle because AB is perpendicular to BC. So we have this formula. This is probably a more complicated problem than you're going to see on your test. So R plus 14 squared equals R squared plus 28 squared using the Pythagorean theorem. Okay? So when we expand this out, you have R plus 14 times R plus 14 equals R squared plus 784. Okay? Doing FOIL, we end up with R squared plus 28R plus 196 equals R squared plus 784. Okay, we have an R squared on both sides. So those are actually going to cancel out, leaving 28R plus 196 equals 784. 28R equals 588. And dividing by 28, we get R equals 21. So the radius is going to be 21 feet.